here we're going to do a couple of problems out of section 10.7, which the calculus part's pretty easy, but we start to see a couple of the application types that we'll see throughout the rest of the course. There are a couple of formulas that you'll see as we go through this material. This is one of the main ones. Profit is revenue minus cost. So revenue is the amount of money you're bringing in from selling something, and cost is the cost that you have going out to have the materials or to produce the object in the first place. So, so our profit is how much money we bring in minus how much we spend. So it's an easy enough idea, and in a problem like this, there's really not a whole lot else to do. The one thing that I want to emphasize here at the start is the word marginal. The word marginal always just means the derivative. So if you see marginal profit, that means that you need to first find the profit function, and then you're going to find the derivative of the profit function. And so there's two steps involved in this problem. This answer here will be your derivative of your profit, and the profit function is the revenue function 9x minus 0.08 x squared minus cost. Cost is 290 plus 0.1x. It's very important to remember to put parentheses around these two things. This entire thing is revenue, this entire thing is cost, and they're being subtracted. If you drop the parentheses, then there's a good chance that you're going to mess up somewhere along the way. Now, you can either simplify this expression before you take the derivative, or you can just take the derivative of every single piece through the entire expression and simplify it at the end. Either way works fine. In this problem, x always represents the number of items. So x is number of items, and that's either the number of items you produce or the number of items you stock, depending on the example. And the y-coordinate here, the p of x, is in dollars. So p of x is measured in dollars, and so the units for marginal profit is dollars per item. So when you have p prime of x, that's dollars per item. So in other words, it's how much profit you get for each item. In this problem, this is problem 4 from that same homework set, we actually try to get a feeling for what that actually means. When we find marginal cost, so let me just do that here. So marginal cost means derivative of cost. And in this case, this is the cost function, so we know the derivative of 1900 is 0, the derivative of 80x is 80, and the derivative of 0.6x squared is 1.2x. So this is marginal cost. So if we want to know the marginal cost when we're at a production level of 50, C prime of 50 then would be 80 minus 1.2 times 50 is 60. So that's $20 per item. So in other words, when we're at a 50 item production level, then our cost is approximately $20 per item. And so that's a good estimate for the cost of the 51st item. If I say that when I get to a production level of 50 items my cost are $20 per item, that means the next item I produce, I'm expecting it will cost me $50. So that would be an approximation. $20 per item is our marginal cost. That would be an approximation of the cost of the 51st item. So that's the answer to part B. Part A, if we really want to know exactly the cost of the 51st item, well, we could just take C of 51, because that's how much it costs to produce 51 items, and subtract C of 50. That's how much it costs to produce 50 items. So if you subtract C51 minus C50, I'm not going to do it here, but that will tell you exactly the cost of the 51st food processor. So that would be the answer to part A. And what you should see is that your answer to part B is a good, quick approximation. It's much easier to do part B once you know calculus, but that gives you a nice, quick approximation for the answer to part A. So that's a good way of thinking about what marginal analysis is telling us, whether it's marginal cost, marginal revenue, or marginal profit. This is the trickiest problem in the problem set because it's a word problem, and we have to figure out in this question what are our cost functions, what are our revenue functions, all of that stuff has to be figured out. So, so I'm going to set up the first part here and then do the second part as part 2 for this video, so that you can see the basic idea of it here, but if you want to see the entire thing worked out, you can just go to the next one. The main thing here is that they're going to tell us some data about what's called the price-demand equation. That's this thing, this relationship between price and demand. They say assume that it's linear. Well, that's a huge assumption, but it makes life a lot easier. That means that we're assuming that the price-demand equation, so we're going to have this be price, and this is price, not profit in this problem, price, and this is demand. So X, again, just like it was in the other problem, is the number of items. In this case, you are selling hamburgers, so it's the number of hamburgers. So that's our X. So what are we told? Well, we're told that when we sell 4,500 per night, so if that sales level of 4,500 per night, that's how much we sell when we charge $2.50. So $2.50 would be our price that we're charging, right? This is dollars. And so we're saying that this point gives us a point on the price-demand curve. The idea of the price-demand curve is that we believe that the price you charge influences the number that you'll sell. And so what we do is we collect data based on how much we charge and how many we sell at that price. So the data tells us that at a price of $2.50, we're able to sell 4,500, but if we raise the price to $3, then our sales will fall to 4,000. So we're told that we have these two data points. And if you read through the first 2 sentences of this problem, that's exactly what it's telling you. But they tell us that the function is linear. So that means that there's a line that goes through these points that's supposed to give us our relationship between price and demand all the time. How do we find that? Well, that's just the equation of a line. So this line goes through these points. The point 4,000, comma 3, that's my x and y coordinate for the first point, and my second point has x coordinate 4,500 and y coordinate 2.5. So I just need to find the equation of the line through those 2 points, and that's what we did during the line review stuff. Now the numbers here are kind of messy, so they're not nice numbers, but we should be able to follow the same process. So I'm going to pause here and start this on the second part of the video.